logical implication is a conditional relationship between two statements, which is represented by antecedent P and consequence Q. Antecedent is hypothesis or conditions, while consequence is result or conclusions. In the derivative form, it will sound like this: if antecedent, then consequence, or antecedent imply consequence. In the simple forms, antecedent, conditional, consequence. Let's look at their true value of antecedent, conditional, consequence. There are 3 of true, while 1 false. So we can conclude that when P is true, while Q is false, the implication becomes false. Otherwise, implication becomes true. Let's look at the example that are given. For example 1, if x is even number, then x is divisible. X is even number is antecedent, while x is divisible is consequence. So we can see that all even number is guaranteed to be divisible, unlike odd number. For an example 2, if Abu is sick, then Abu will not go to school. Abu is sick is antecedent, while Abu will not go to school is consequence. This statement becomes false only when Abu is healthy, but will not go to school. Let's look at how logical implications connects one argument with another argument. Argument is a structured way of thinking that uses premises in establish a conclusion. Premises is statement that is evidence. Conclusion is statement that is made derived from premises. General structure of argument is P1 conjunction, P2 conjunction, P3, so on and so on, conditional Q. For an example, let's say kids like lollipop is premises 1. Ideal is a kid is premises 2. Therefore, ideal like lollipop is conclusion. The structure for the example is P1 conjunction P2 conditional Q. Let's look at how to check the argument is valid or invalid. A logical argument is valid if whenever all premises are true, then the conclusion is also true. In other words, validity of an argument means that true premises guarantee a true conclusion. One way to establish the validity of a given argument is to show the statement of implication is a tautology. Truth table can be used to determine the validity of some arguments. An argument is considered invalid when all true premises do not result in a true conclusion. Let's look at the example here. Bracket P conjunction, another bracket, Q disjunction, negation P, another bracket, implies negation of Q. By using the truth table method, we can see at the last column shows the truth value is not tautology. Hence, argument is invalid.
Rules of inference is basically fundamental principle in logic that describe the valid ways of deriving conclusions from the given premises. It is ensuring that arguments and mathematical proofs are logically sound and consistent. Other than that, it is widely used in mathematics, computer science, and discrete structures to justify each step in a proof to prevent invalid reasoning. And then it provides a formal framework for constructing valid arguments. Overall, it is actually conducting forward and backward reasoning and ensuring that conclusions are logically follows the true premises. Now we have 12 types of proof of inference that we learned. The first one is we have modus ponens, and then law of syllogism. Next we have modus tollens, and then we have rule of conjunction, rule of disjunctive syllogism, rule of conjunctive simplification, and we have rule of disjunctive amplification, rule of contradiction, rule of conditional proof, rule of proof by cases, and then we have rule of constructive dilemma, and the last one we have rule of destructive dilemma.
I will explain how to solve the question based on the truth table by using truth table. So based on the question, we have three premises, which is P implies Q, not R implies P, and not Q. So we will combine all the premises into one argument. We will use the symbol N. And to combine the premise, all the premises, we'll use the implies symbol. We will get bracket not P implies Q, and not R implies P, and not Q big bracket implies R. So that will be our argument. So based on the truth table, we will get 8 rows and 10 columns. So the first column for the P, we will need to put the first until the fourth row with 0 and the rest with 1. While for the Q, the pattern will be 0, 0, 0 and 1, 1. So the first two will be 0 and the third and the fourth will be 1, and the fifth and the sixth will be 0 again, and the 7 and 8 rows will be 1 again. So for the R column, the value will be 0, 1, 0, 1, 0, 1, 0, 1, and 0, 1. The fourth column for the not Q, we will put the value opposite of the Q. So for example, if the value of Q is 0, so the not Q is, the value for not Q is 1. Same go as the fifth column for the not R. And then for the this column, P implies Q, we will get the value based on the first and the second column, which is for the column of P and Q. For example, if P is 0, then Q is 0. So 0 implies 0, we will get 1. We will get 0 for the P implies Q when the value is 1 implies 0. Same goes for the not R and P. We will get the value based on the not R column and the not P column. Next column will be P implies Q and not R implies P. We will get the value 1 when the value is 1 and 1, and the rest will be 0. The ninth column, we will get the value based on the 8th column and the 4th column, and the pattern will be the same. Both value is 1, so 1 and 1 we will get 1. The rest will be 0. For the last column, we will get the value based on the 9th column and the 3rd column. And we will use the implication, which is 0 implies 1 will be 1, and 0 implies 1 will be 1, and all of the implication will be 1 unless there's a value which is 1 implies 0, then the answer will be 0. After we solve all the question, we will get the last column will be, all the value for the last column will be 1. So which means it is tautology. So in conclusion, we can say that since the column shows the implication is tautology, therefore the argument is valid.
So today I will do to determine the conclusion of this argument. We must apply formal rules of inference to the 4 given premises. So the first one is a biconditional statement, which is P biconditional Q. So the second is a conditional statement, which is P conditional R. And third is disjunction S or not R. So the fourth is a negation, not S. By following this step, we can derive the final logical conclusion. We begin with step 5 by looking at premise 1. Because it is a biconditional, we must use conjunctive simplification to extract the first direction of the relationship, which is if Q then P or Q conditional P. Next, we must link step 5 and premise 2 together. Since Q leads to P and P leads to R, we use the law of syllogism in step 6 to establish that Q conditional R.
In step 7, we look at premise 3 and 4 since we know that either S or not R is true, but premise 4 tell us S is false. We must apply disjunctive syllogism to conclude that not R is true. Once we have confirmed that R is false, we can go back to step 6. Since Q is supposed to lead to R, but R is false, we must use modus tollens. So in step 8, to prove that not Q is true, in step 9, we must return to premise 1 again because a biconditional work in both directions. We use conjunctive simplification once more to extract the second half, P conditional Q. Finally, for step 10, we must apply modus tollens using the relationship we just found and our result from step 8 earlier. Since P leads to Q, then we have proven that Q is false, then P also must be false. This giving us our final conclusion, which is not P.
Today, I'm going to demonstrate how to analyze a logical argument and prove its validity using rules of inference. So our argument focus on an athlete's journey. If they train, their stamina increase. If stamina increase, they will break a record. If they break a record, they win gold medal. Since the athlete attend all the training session, we want to prove they will indeed win the gold medal. So, for the first question, we need to translate those English sentences into logical variables so we can work with them mathematically. Let's define our primary statement with P, Q, R, and S. So, for P statement, athlete attends all training sessions. For Q, their stamina will increase. For R, they will break their personal record. And for S, they will win the gold medal. So, for the second question, let's look at the structure of the argument. Based on the if-then relationships, we can list our premises and our conclusion using the arrow to right symbols. In logical mathematics, we call the symbols as implies. So, for the first premises, we have P implies Q. For the second premises, we have Q implies R. The third premises is R implies S. And the last premises is P. So the conclusion is S. So for the third question, to prove this is valid, we use a step-by-step chain of logic. So follow along with the table on the screen. By combining premise 1 and premise 2, we use the law of syllogism. The law of syllogism says that if P implies to Q and Q implies to R, so directly P implies to R. For the next, we apply the law of syllogism again. We take our new statement, which is P implies R, and combine it with premise 3, which is premise 3 says R implies S. So this gives us a final if-then chain. If P happens, then S must happen. P implies S. Finally, we look at premise 4, which tells us that P is actually true. Using modus ponens, if we know P implies S is true and P has happened, then S must be the result. So, because we reach our conclusion S using the rules of inference, the argument is logically valid.
In conclusion, logical implication is a principal notion in reasoning and problem solving. It helps us understand the relationship between condition and outcome, lay the foundation for constructing and analyzing arguments. We have looked at how argument is structured, with premise connect to conclusion, and how rule of inference is used in reaching logical outcome by truth table method and identify tautologies. Therefore, we can evaluate validity of argument systemically and distinctly. The example shows that these ideas are both theoretical and practical. Thus, understanding logical implication, argument, and rule of inference is essential for honing our reasoning skill and improve our critical thinking.